So were you able to read this article that I suggested? So anybody who wants to go ahead. So there was this article about policy that the Indian government is planning to release, right, of having an open e-commerce platform. So essentially the idea is that today we would have to choose, right, whether to buy something from Amazon or to go to Flipkart or one of the other e-commerce platforms. So here the idea is that all platform providers will have to provide open APIs so that anybody can query them for prices and various things. And similarly, there are any other stakeholders in the ecosystem like delivery companies, right? So all these APIs should be provided so that anybody can choose and query what are the products being shown on Amazon or Flipkart, and then they can choose which one they want to buy, right? And this is basically being projected as creating an open market, which is going to be entirely API driven and composable. So anybody can come, they can search, and this search will essentially query Amazon, Flipkart, and all sorts of providers and show the compiled results. And then you can choose which one you want to buy from. And similarly, you can attach for delivery. You can similarly search across different companies, and you can attach a delivery company. Then similarly, you can search for different payment gateways and attach a payment gateway, right? So that's the idea. So were you able to read, and any thoughts you have on any issues this can cause? Is it going to solve partly the problem that it's trying to? What is the problem basically that it's trying to solve? Yeah. So anybody who wants to go ahead?
The problem is the fair pricing across the different websites where the persons may show different prices on different platforms or may expose himself as a multiple providers under the different names. So that might be people might be able to cache some of the issues, or they can also, I believe, along with that, there would be some kind of review or feedback systems for the providers. So that would help things to be regulated, as well as people have a more choices to or clear choice to decide where to get the products from.
Hmm. So essentially, the idea being that it will increase more competition, right? That's the whole logic of the market. That if it is easy competition, meaning that the information is also visible to people, right? Because otherwise, if the information isn't visible to people, then you might not have a competitive market, but just because people are not exposed to all the choices, so they don't know, right? So that information asymmetry will lead to a loss of competition. So here the idea is that you make through the APIs, you make the information available to everybody, and that will increase competition, and consumers will then get a fair price, right? So Amazon and other companies will not be able to dictate prices as such. Yeah. And right, so but what do you think, right? Is this going to solve the problem? What technological issues would also need to be solved so that it lives up to the promise? Yeah, anybody?
Sir, maybe this, like, as the government claims, like a lot of merchants can come to the platform, but maybe the rural people would not be there were previous apps launched for rural people where government tried to bring in e-commerce, but the problem was that the small farmers were unable to like adapt to this technology directly. So either the government should also set up some like educational centers or like assistantship centers in small villages where like they are taught how to use this.
That's an important point. Yeah, that it will not open up competition in certain markets, right? Only those who can access this market, and therefore it's not going to solve problems for rural consumers, for example, right? So this is something we'll examine in more detail when we talk of system design. That overall, once you do design a system, ultimately who is it benefiting? But let's say over here, our world is narrow, right? Let's say like everybody can access the internet, right? Hypothetically, or maybe it's just meant for urban consumers who would want to pay for some of the goods being sold online. There, any problems you foresee? So one of the things we talked about last time was search interfaces, right? There is so much of information available out there. You cannot look at all of the information, right? And that is why you need some gatekeeping algorithms, right? That's where search engines come in. And then last time we discussed how search engines can create this feedback effect based on what is the ranking algorithm being used. Yeah. So if the ranking algorithm is sort of based on popularity, right, then it reinforces, it creates this feedback loop that whatever is already popular ends up becoming more and more popular. Right now, even in this setup, you will need some kind of a search interface, right? You can query everybody, but ultimately there would need to be an app, right, or some interface created on this open platform, which is then what the consumers are going to go to, right? So instead of going to Amazon or Flipkart, they'll go to this open platform and search for whatever product they want. And this guy will at the back end query Amazon, query Flipkart, everybody, and show the results, right? But how are the results being ranked? What are the metrics being used for this ranking, right? So if the metrics are going to talk about delivery time or number of existing customers, right, then and that's what the ranking is going to be based on, then Amazon and the established players are going to continue to get a higher ranking, right? It's not that anybody new who comes into the system will be able to compete effectively, because all these players already have a strong track record, right? So it's not really going to displace them, right? It will still continue to be hard for competitors to emerge if the if the algorithms embedded in this gatekeeping search interface are going to use some of these metrics. Yeah, and you would need some of these reputation metrics, right? Because otherwise, on what basis do you rank anyway? Right, so that is something that will be important, right? That the ranking metrics, just like in the search interface, we were saying that, well, okay, maybe some part of the result is based on prior reputation, but some part is where you're encouraging, you're supporting new players to get discovered, right? So that the discovery is fair, right? So that's one part, yeah, that the algorithm, right? And the second part also, which is important, is in terms of on what metrics is it being ranked, right? Are some metrics even possible to compose together, right? Because now in this kind of a system, let's say you start using something like a consumer rating, right? Now you want to keep it simple for consumers, so the rating interface will, let's say the consumers are able to rate the eventual service as between 1 to 5. Yeah. But the fact is that their rating will be dependent because the service is composed of many other sub services. Therefore, the rating that a consumer gives could be based on the price that they got, could be based on the quality of the product that they received. It could be based on some other issues that they encountered, maybe with the delivery, the logistics of the delivery. It could be maybe they ran into some payment errors. It could be because of the payment gateway, right? So if you just use something based on ratings, it's actually going to be difficult to pinpoint that, okay, how much of this rating should I attribute to Amazon, or how much should I attribute to the logistics delivery partner, and so on, right? So that again is an issue that becomes important, right? That what should be these ratings or even metrics that you decide, right? So now recall, we saw this paper on Facebook, right? Metricization, and that was one of the issues, that the metrics you choose can actually also be biased in the sense that some metrics would inherently favor some entity. Yeah. So that is another important aspect that needs to be thrashed out before something like this can really lead to the benefit that it is promising. Yeah. So in fact, it's very interesting. Overall, it's a radical concept, right? No other country has done something like this, right? So it's a radical concept, but what many people are concerned about is that it won't really solve the kind of issues that it's trying to claim that it will solve, which is about, right, creating more fair competition and so on, right? So the whole argument is that even this system it's not like it's going to displace Amazon or something. You need a lot more discussion and processes in terms of like defining metrics, what metrics to use for ranking, how should the ranking algorithms operate, right? So that's one part on which, right, based on which this can happen. Yeah. So in fact, if you've been following, and I'd encourage this also as part of project ideas, which by the way, again, I'll emphasize, I've only heard back from 2 groups so far. And even to those groups, I've given a lot of feedback, right? So the initial idea with which even these groups had approached me was nice, but not fully thought out, right? So I've given a lot of detailed feedback to thrash out the ideas further. Right, so those who have not sent me, those who have not written to me about project ideas, please do that ASAP, right? Because otherwise you will be in trouble, right? The courses, of course, will keep moving on. We need to have presentations. We need to have your final project ready, right? By a particular date, and it's linked to your grades and everything, right? So please, right, make sure you're keeping up, right? Otherwise, it will become very hard towards the end if you just delay everything in the usual way to the last minute. Right here you have to. It's a project plan first of all that you have to prepare, right? So you need to do that well. Yeah. So one of these ideas that I also propose in the project is India is also discussing, or rather, it's putting into place a whole strategy called the National Digital Health Mission, National Digital Health Blueprint, and as part of that, they're thinking of a very similar system which they call the Unified Health Interface. So the idea is that health providers, right, individual doctors or hospitals, right, with different categories, right, with physiotherapists, doctors, different types of doctors, different hospitals, different specialities, right, they will all put up their information in terms of certain metrics like outcomes, right, how many people come to them, how many people are satisfied, how many people have been treated well, and so on. As a consumer, I will be able to search for providers in my area. I'll be able to look at ranks of these providers. When I search, I'll get a rank list of providers based on which I can select who do I want to go to, and so on, right? So part of the claim being made is that currently none of this information is digitized, and it's very difficult for you to find out, right, what's the best hospital or who's the best doctor that I can go to based on whatever factors would be important for me, fees or whether I have insurance, and so on, right? So this will make all of it discoverable and searchable, right? But again, the same issues arise over there as well, right? That on what factors are we ranking, right? Or what are these metrics on which we are ranking? So treatment, for example, right, is complex. I might go to a doctor, but then this doctor might refer me to another doctor. Maybe I also need to get some tests done, and so on, right? And eventually the outcome or even my experience is dependent upon so many different services that I would access. So is it even possible to compose all of them together? Yeah. Then there are attached to it also privacy issues, and even in the marketplace platform, privacy issues will come up, right? So if ratings are based on how many people avail the service, well, should you give an exact number? Should the providers give an exact number, or should they? Because then it becomes cases like we've seen with differential privacy, de-identification, right? So if you're able to query that how many people were treated by a doctor for this particular for HIV, let's say, in this pin code, right? So same thing, right, as what we saw, the same question that we saw, right, that it is possible to de-identify. Now if we open up these interfaces, then these kind of queries can be launched and you can actually get some of this information, right? So again, it becomes important to also think through differential privacy like solutions. Similarly, in the health setup, right, same with e-commerce, right? If somebody wants to mine all of this data in aggregate, let's say from a public health perspective or in e-commerce, just to understand more broadly, right, how many consumers are there, what are they doing, how satisfied are they, so that we can build better policies, right? So again, even in this data analysis, you then get into privacy issues. Yeah. So the broad point basically is that you need to examine these systems in a lot more detail, right? Because the way they are marketed typically, and the claims that are made about the problem that the system can solve, there is typically a lot of overselling that happens. Yeah. If you examine them in detail, you will find out that it's not that straightforward to realize the benefits that they're talking about. Right? You need many things to be right before that, before you can actually realize these kinds of benefits. Yeah. And right, same just like with politics for that matter, right? So many promises which are made, but then actually if you think about it, it's very hard to keep up those promises, right? Because here there might be vested interests, right? There would be vested interests in terms of who's pushing these open protocols, right? And with UPI, for example, the unified payment interface. So again, it's a radical concept. No other country has it, and they're trying to learn from India's example, right? Which is great. That it's a unified interface through which anybody can make these transactions, and therefore it enabled a lot of startups to come in and attach themselves with payment services. But it did not really lead to a level playing field, because what the way it happened is essentially that the people who built this whole UPI concept, these are actually the same people who were typically working in different financial companies, fintech companies. So they, as volunteers, they came together and they built this whole concept of UPI. But because they already knew about this beforehand, it is their companies that were able to also benefit from it, right? So that's one of the issues that has been highlighted, that the incumbents never got really displaced, right? Partly they were because they were able to take advantage of it more quickly, and also in many cases they actually proposed these systems because it was going to benefit them, and then they saw that opportunity, right? So there are these, I mean, inherent issues, business incentives and so on, which might be driving many things. It's just that it's projected in a different way. It's projected to the public as something which is going to lead to a more egalitarian world, but actually it may not be so. Right? So this is where we need to critically examine these technology systems that are being proposed. Yeah. So let's begin on where we left off, right? So here we saw these feedback effects from like gatekeeping applications like search engines and so on, right? That we saw that they do have psychological effects on people, right? Based on what people see, it changes their perception. Same with news feeds, right? Facebook's news feed. So this experiment actually showed that the news feed is not tweaking what you would otherwise see from your social network, right? So in one sense it's arguing that the news feed is neutral, but in the other sense it's also showing that, well, I don't care, right, if people get articles which are in line with their biases, right? So it's not my responsibility to fix those biases and perceptions, right? And then the important part that we were discussing, which we'll go look at in more detail today, right, is basically stereotype bias, where certain social groups can be harmed when you have algorithms making automated decisions, right? So this was an example with face recognition, right? That the data sets on which the face recognition algorithms were trained were mostly of white people, and therefore it was performing better on white people. It would make more mistakes on black people. Right, so this hadn't been known earlier, and this was tested on different benchmark data sets and so on, where they showed that this is the case, right? So here you actually have the sample which is not balanced in terms of different subclasses or different social groups, right? And therefore you need to make sure that you have that in the data set that you're learning from, it's not that some group is overrepresented than other groups, right? So that was one. The more interesting, and which has seen a lot of study, right, is which study which came out on prediction of risk scores for sentencing or whether to grant bail to somebody or not, right? So here one of the issues was measurement bias, because what the variable that you actually want to predict is whether a person is likely to re-offend or not, right? But this variable, the ground truth is not easy to measure, because to measure whether somebody is able to will re-offend or not, you need to track them, right? That once you do release them, what happens? But this tracking is biased, because this tracking is done more for blacks than for white, because black neighborhoods are more actively policed than white neighborhoods, right? So therefore the data which was used is essentially a proxy for re-arrest and not re-offending, because re-offending across all for everybody who's been released is hard, and therefore you use data of re-arrest as a proxy that somebody re-offended. But re-arrest is essentially biased to neighborhoods, black neighborhoods, which are more actively policed, right? So whites might be re-offending, but it's just that because you're not policing them, you don't know, right? And therefore you've not really arrested anybody over there. So the data was inherently biased that blacks are more likely to reoffend, right? That is what was causing this. Then what also happens is that if, let's say, you say, well, okay, I will blind my classifier on race. So I will not even feed race as a variable into my classifier. Let it decide based on other variables. But here the problem that happens is that of correlations, because race is correlated with many other variables. So if your classification algorithm is using data on education background or income, right, that or neighborhood, right, the pin code, then that is again correlated with race. And therefore, even if you blind your classifier, you don't feed it a race variable, even then it's not going to solve the problem, because that information is actually, the classifiers will learn that from other variables. Right? So this is one of the things we saw that, well, so this is another example where instead of predicting reoffending, right, you're trying to determine whether to give loan applications or not. Right? Success rate of loan applications, and there are 4 racial groups over here: whites, blacks, Hispanics, Asians probably. And if your classifier is just trying to maximize overall accuracy so that you can maximize your profit, right? Don't give loans to somebody who's more likely to default. Then there's a lot of disparity. Some groups are getting a very high rate for loans, some groups are getting a very low rate for loans. And this disparity doesn't get addressed a lot even if once you make a classifier race blind. Right, so you need other things to be done, right? And what we saw last time was that this is what you call fairness, right? But fairness can be defined in many different ways, and different, if you ask different people, they would have different notions of fairness that are important for them. Yeah, right. So the decision maker, like a judge, right, will say that for me, I want to show that I have made a good decision, right? That of those I labeled as high risk, how many are actually reoffending, right? And this I will show that I have been very fair, because of those I labeled as high risk, it's the same probability for that I was correct for blacks as well as I was correct for whites, right? So when you look at this matrix, right, that of all the people I labeled as high risk, now over here you have a few black people, you have some white people, black people, white people. In each cell you have black people, white people, black people, white people, right? So of those I labeled as high risk, which is this, right? Black here plus black here. Upon those, right? So this is the denominator. The numerator is how often was I correct, right? That those I labeled high risk, how often was I correct? So I take blacks here upon blacks plus blacks, and that is nearly the same as whites here upon whites here plus whites here, right? Right. So that's what the decision maker is trying to say. Right, now you can actually look at this formally, right? So this is now something called sufficiency, right? That right. So here now these are the variables. So this is actually a open source book. Open book. Fair ML by Arvind Narayanan and others, openly available, right? So this is definitely something you should go through, right? So right, you can define all of this formally, that there is a target variable that I want to predict. This prediction is based on a classifier output, right? And there are certain sensitive attributes that I want to make sure that I'm not biasing on them. So this particular decision, where we're looking at the judge and what is important for the judge, is something called, formally they define it as sufficiency. That basically there was some relationship between the target variable, which is rear S, and sensitive attributes A, right? But what the judge has done is that the judge has put a classifier, right, himself or herself in between, such that the target variable is now independent of the sensitive attribute, given that now there is a judge in between, right? So another way to understand it, this is easier to understand, that probability that the person will actually get rearrested, right, given that it's a black and I predicted that they'll get rearrested, is the same as the probability that if the person was a white person, right? So if the person was a white person and I predicted that they will reoffend, then how often have I been correct in that prediction, right? So this is the notion of fairness, which you can now formally define, which is important for the judge, right? Which is important for the judge over here. Yeah. But if you ask the person, right? If you ask the person who is actually being questioned, right? Should this person be on bail or not? For that person, actually, the notion of fairness would be different. That person will want to check that what is the probability that I'll be incorrectly classified as high risk, right? That false positive, right? That I've been labeled as high risk, but actually I did not recidivate. I will not reoffend, right? True negative plus false positive. So black here upon black plus black over here, it should roughly be the same as if I were a white person, then white over here upon white plus white over here. Yeah, right. So that's what this defendant would actually want, right? And again, formally, that's it's called separation. That the relationship between the score and the sensitive attribute, right? That right, the chance that I'm going to be labeled as high risk, right, is right. So that is only justified to the extent that I will actually reoffend or not, right? So again, it's easier to understand in this way, that, or rather even the false positive one, that right, that probability that I'll be predicted as reoffending, given that, but I will not actually reoffend and I'm a black, should roughly be the same as the probability that if I were a white, right? Probability that I would reoffend, the classifier will say that I will reoffend, given that I will actually not reoffend and I'm a white, right? So that it doesn't make a mistake, right? Same for true positive rate, that probability that the classifier will say that I am likely to reoffend, given that I will reoffend and I'm a black, should roughly be the same, right? That even if I were a white person. So this is called error rate parity. This is called predictive parity. This is called error rate parity or separation, right? So now for the defendant, this is actually an important criteria. And then from a society's point of view, right? If you and I as external observers, if we want to look at it, right? Then, right, so here hiring is a easier example to think about that, right? We apply for that, we see people applying for jobs, right? So what's a fair notion? That there should not be discrimination for when blacks are applying for a job or when whites are applying for a job, right? So as a member of society, we would say that there should be something like a demographic parity, that there should be an equal chance that if I'm a black applying for a job, there should be an equal chance that I'll get a job, versus if I were a white person applying for a job, right? So chances of getting selected, whether I'm a black or a chance of getting selected, is independent of whether I'm a black or a white, right? So that's called independence, right? That probability that I'll be selected given I'm a black is the same as probability I'll be selected given if I'm a white person. So, right. So now the very interesting thing is that if you start thinking in this way, right, then it's actually forcing you to formally define what you mean by fairness, right? And there are many ways in which you can actually define fairness, and different people will have different notions based on their context, their function, right? So like we saw, the judge once has a different notion of fairness in terms of whether his or her decisions are right. So they're essentially evaluating the quality of the decision, right? Defendant is doing something else, right? Defendant is actually trying to make sure that, well, if I'll be mistakenly denied bail, then are whites also going to be mistakenly denied bail at the same rate, right? And society is thinking of something else, right? So one other interesting bit is that there are impossibility theorems which show that, well, you can't satisfy all of these at the same time. It's inconsistent, right? So that's one part, right? But that you can't have independence as well as separation as well as sufficiency, right? And there are many such similar definitions that you can also come up for fairness, right? And different definitions are important for different people. So the point becomes that you therefore need to choose, right? That if you're defining it formally, right, which is probably good, that it's forcing you to think that what is the fairness that I'm considering is important. But then it also needs you to clarify that, okay, who is this fairness important for, right? So that becomes another important point over here. Yeah. So we'll probably not go into a lot of detail here, but this is just to give you a sense that what is this whole fairness in ML area all about, right? So machine learning, as you know, right, is essentially, it tries to minimize a loss function, right? Loss function meaning that maybe, okay, I'll just quickly show this on the board. Loss function meaning that if you're doing a linear regression, right? So here, this is some y that you're trying to predict. You have x over here, and right, there are different points here, and right, you want to basically find out a relationship which can between y and x, right? And the way you then do is you try to minimize your root mean square error, right, from this. So that's the loss function. And in a similar way, right, if you have variables of this sort, right, where you have a bunch of points here, and this is y, which are close to 0, and a bunch of points over here, right? So there is some overlapping. So there, instead of fitting a linear regression, you try to fit a logistic function, right? Similarly, there are all sorts of different methods that you can use, right? So one method is that if you have a setup where over here there are a lot of points, over here there are a lot of points, then you fit something, right, called the radial bias function, right? So you can try to fit different, essentially you're trying to fit different models to the data, right? That's what, and in each of these you're trying to minimize a loss function, right? The loss function would essentially be measuring the gap, right? The gap from the actual data points on which you're training it, right? Right, and the way these are essentially measured is using the gradient descent algorithm, right? That you essentially you first try to estimate certain parameters, and then you readjust those parameters in the direction in which you're getting the most benefit. The gradient is the maximum, and right, these are convex functions, so you then will converge towards the local minima for the loss function, right? So what fairness notion is basically trying to do is that instead of just always minimizing the loss function, that is, you're always just following the gradient in the maximum direction, you impose some constraints. You impose some constraints that I will not move the gradient in certain directions, right? So that's the constraint that you put, which is the, so I'll just come back to the screen. This, right, whatever is the fairness definition that you're using, right? So instead of always just minimizing the loss function and moving in the direction of the gradient, you will minimize the loss function, but subject to a particular constraint, right? That you will only minimize the gradient as long as this constraint is always obeyed. And what is this constraint? This constraint is the same as the fairness definitions that we want to employ, right? So this is independence or demographic parity, that prediction that, right, I will minimize it subject to that whatever I'm predicting given blacks is the same as whatever I'm predicting given whites, and it's within this error bound, right? Within some error bound, right? So you can define that, okay, I will define an error bound of, let's say, 20%, that probability that it will differ between blacks and whites will not be more than 20%. So this is just at a very high level, right? That machine learning algorithms are basically depending on whatever classifier you're using, whatever model you're trying to fit to the data, they're trying to minimize those corresponding loss functions by following the gradient descent method. But what the fairness is doing is that it's basically just minimizing, but subject to that this constraint is not violated. So essentially, you're not just completely freewheeling in your gradient descent to always just follow the path for minimizing the loss, but you're constraining the neighborhood in which you search, such that you don't go into a neighborhood which is going to cause a lot of this disparity. Yeah. So that's the basic idea behind trying to make machine learning algorithms more fair, right? So it requires you to, however, first define a notion of fairness and then to implement it in the solution search. Yeah. Right. And whatever we've discussed, this is called group fairness, right? Because we're essentially trying to see if on aggregate we are being fair to blacks or whites or men versus women and so on, right? But there are other definitions of fairness also, which are individual fairness, right? Because the point is that in group fairness, it's possible that you could have a situation where for some blacks it worked well, but for some other blacks it did not work well, right? So just because you wanted to ensure a group wise parity, you could be unfair to specific individuals. So what the notion of individual fairness basically tries to do is it tries to measure similarity, that, and then it tries to check that anybody who is similar on certain features, decisions about them should be similar, right? So that is another thing. Now you can think about even formally defining it based on the input features or some set of input features, right, which are not sensitive. That as long as people are similar in terms of education background or income background and so on, therefore predictions about them should be similar. Yeah. But again, you can see that this individual definition of fairness may not really solve discrimination against social groups, right? Because if you just build a notion based on income and education and so on, you know that, well, blacks are disadvantaged. So you actually need something like an affirmative action, right? That thresholds for blacks would be lower than thresholds for whites and so on, right? So ultimately the bottom line is that in these algorithms, you therefore have to encode, right? What are these fairness definitions that you're actually using? And many of them are not compatible with one another. And you need to also figure out that from whose perspective are you thinking about it. Then there's, of course, I mean, this is a very, very active area of research, right? So people have seen many things that it's sometimes better to learn different classifiers for different groups, right? So instead of learning one classifier, which you're now trying to ensure that is fair for men and women or blacks and whites, it's probably better to learn different classifiers, a separate classifier for women, a separate classifier for men, because their behaviors are different. And then you try to ensure fairness one layer above that, right? That then you can impose some constraints that, okay, I want to have so many % of my staff as women. That's my goal. And then I'll use a different classifier to identify resumes of women which are going to be better. And similarly, another classifier for identifying, sifting through resumes, CVs of men to identify which men are are better for me to hire. Yeah. So again, in the interest of time, I'm going to skip this, right? But right, it's an active area, right? So similar to classification, there's also things about trying to ensure fairness in ranking, where essentially you see that a ranking that you're generating, there's a particular utility that you will derive by placing an item at a particular rank, right? But you want to maximize that utility subject to certain constraints that in the top K positions, let's say, the ratio of results about, let's say you're trying to search for like political candidates, right? So in the top K, fraction of results about one candidate will not exceed some particular threshold related to results about another candidate, right? So then you want to find a ranking which is maximizing the utility meaning, let's say, the quality of the page based on the inherent quality of the page and so on, or popularity. So you're trying to maximize the utility, but also subject to a constraint that the ratio of candidate A to candidate B will not exceed some particular threshold, right? Same in terms of classification, that you define a ratio, right? Similar to, right, you define this epsilon, that how much can this deviate, right? And then you do your classification such that this deviation is not ever more than a particular threshold, right? And that's ensured by this constraint imposed during the solution search, during the gradient search. Yeah. So again, this is an interesting notion, right, called the Pareto frontier. That essentially now what you're seeing is that if you're trying to do this, right, you're trying to minimize a loss function subject to a fairness constraint, right? So naturally, because you've imposed a constraint, you will never get to the minimum loss if you did not have the constraint, right? Because now that particular global minima, you're saying, I don't want to go to that global minima because it has unfairness. I will rather try to search for another position which is not as unfair, right? And it obeys this constraint. So this essentially leads to a trade-off, that you're essentially trading off fairness with accuracy, right? Or right, error with unfairness. So here the idea is that if you have a particular solution over here, let's say, right, and you're tolerant of that particular error. So you're saying that, okay, I'm okay with an error of so much, but should you choose this solution? So the idea is that no, don't choose this solution, but rather choose a solution which has less unfairness, right? So this is basically called the Pareto frontier, that you might have many solution configurations, right, with different errors and different fairness, but you want to choose solutions which lie on this Pareto frontier, right? That why is it called the Pareto frontier? So the notion of Pareto is that can you choose anything which maximizes something but doesn't worsen the least well-off person, right? Similar to Rawls' notion. So recall that, right? That's where a lot of this is coming from, right? So that's what it's then trying to do. That, okay, rather than, so if you have a particular error that you're comfortable with, you shouldn't choose anything over here, but rather try to find out which is the least unfair. Then here's some more interesting, right, other problems which can arise, something called intersectionality, right? That, right, circles are, let's say, blacks, squares are, let's say, whites, right? Two different races of people, right? And you're trying to ensure fairness among on this race variable, right? So yeah, you have a similar fraction of let's say error rate over here, things which are classified correctly, classified incorrectly, which are, right, let's say incorrect classifications are these black dots or these filled squares. So between blacks and whites, you have a parity, right? You have an error rate parity. That fraction of times when I classify blacks incorrectly is same as fraction of times I classify whites incorrectly, right? So that's good. But actually, the solution that you found is unfair on another dimension. So, which means that you're making mistakes on black males and you're making mistakes on white females, but you're not making mistakes on black females or on white males, right? Right. So therefore, you need to make sure that if you have multiple dimensions on which you want to ensure fairness, right? So that becomes something again to check for, right? On one dimension, you might use these kinds of constraints, but you might have many dimensions on which you want to ensure fairness in parallel, right? Right, so there are methods again, right, similar, something called an adversarial approach, which is used, right, that, right, you come up with a solution, and then at each step you're checking, right, a regulator is checking whether the solution is fair on all the dimensions or not. If not, then you again readjust and you try to find a solution. Therefore, continuously you're trying to search for a solution where the regulator is checking whether you have parity on all dimensions on which you want to ensure fairness. Right. So again, the point is that there are many such, right, combinations that can happen. So again, in the interest of time, we won't have time to go through this, but right, this is another interesting case. So far we were talking about classification algorithms, ranking algorithms. This is something called word embeddings, which are very popularly used. And they end up being used for classification and other tasks. They end up being used for classification, right, ranking and so on. So it's a tool which is one layer behind wherever you will want to use this, right? So essentially, the idea, the broad idea around this is that words that occur in the same context have a similar meaning. So you learn a particular vector representation for each word, right? Words which occur in the same neighborhood typically then tend to have a similar embedding. So that's what this embedding tells you, right? So you, through a neural network approach, you derive an embedding for each word, right? In a vector space of, so here they're talking about a dimension of 300, right? A vector which has 300 values in it, and each word has a unique embedding. And what this then guarantees is words which occur to similar, close to each other, have a similar meaning, have a similar embedding. And then it becomes interesting that people, however, started noticing, right, that actually these word embeddings which are derived, right, now you're deriving it based on text which already exists, based on Wikipedia articles, based on news articles. So you feed a lot of these articles into these models, and the model then obtains an embedding for each word, right? So that's how you train it, right? You feed it a lot of text. You feed it a lot of text and it derives these embeddings. But then what people started noticing is that there are certain words which are closer to she, like homemaker, nurse, receptionist, and so on. And there are certain other words which are closer to he, maestro, stripper, philosopher, captain, and so on, right? So now you can see that these are typically what are female professions, these are typically what are male professions, right? But you can argue, well, this is historically, this has been biased, right? Because this is what females were doing. But now you also have female architects, financiers, right? Warriors, you have female philosophers, and so on, right? So here, because you fed this data from existing language corpuses, these languages are telling the story of a society which has been biased against women, right? And it's the same biases which are coming into the embeddings. And then the challenge becomes that if you're using these embeddings for something else, right, for classification or anything, the same kinds of biases will then reflect in those upstream systems as well, right? And then there are all these interesting analogies that you can also derive, right? So if you say, if you ask this man is to woman as queen is to what, right? So the embeddings can actually then tell you that, okay, you're likely to get king over here, right? But when they saw that, okay, he is to she as sewing is to what? Says sewing is to carpentry. Right? So these are the nearest embeddings. If you if you take the she and he, a vector based on she and he, and you project sewing onto that vector, then and then you see which is the other word which is closest to it, then it turns out that is carpentry, right? So nurse is to she as right, surgeon is to he, right? Giggle and chuckle, right? So again, these are basically reinforcing what are gender stereotypes. Gender appropriate would be queen is to king, waitress waiter, right? Sister brother, and so on, right? Right, again, right? You talk of girls as lovely, but you talk of boys as brilliant. You talk of girls as using cosmetics, but boys being in like pharma, right? Talking about pharmaceuticals, right? So the point is that these embeddings are biased because of a gender stereotype bias in the language, and this language is basically only reflecting the biases in society, right? So that's the challenge over here, right? I'll just show one of these things. So now these embeddings are then being used for many other things, right? They might be used for toxicity detection in essays, right? For automated grading of essays. Let's say like essays right, or articles you're posting on social media and so on. So the problem is that if there are biases in the language itself, right? Those biases then lead to problems, right? Similarly, if you use these embeddings in resume filtering or whatever, right? So they would then lead to degraded service, adverse decisions. Right? So that's where you want to clean it up. Yeah. So go through some of this on your own, right? There are ways to, right? People then try to measure, right? How much is a corpus, embeddings learned on a particular corpus, are they gender biased or not? Right, or gender or whatever, right, race biased and so on. So there's, right, it's a simple metric which has been suggested that neutral would be 0, but some embeddings which are available publicly, right? So the way this works is that companies like Google and Facebook have, because they have computing power, they have trained these deep learning models on lots of text, right, gigabytes and gigabytes of text. And they have released the word vectors. They have released the embeddings that you and I can use in our classification algorithm. So we don't have to learn new embeddings, but we can use the embeddings that they have already obtained, right? But then it turns out that word2vec is biased, male biased. Glove vectors are also male biased, right? So, right, and therefore now there is an effort to release vectors which are unbiased, right? And here the idea is that you detect the direction of bias. So let's say these embeddings have a vector of size 300. Now you detect the direction of bias between, let's say, he and she, or whatever other such statements or stereotypes you want to counter, and then you reproject everything else on a vector orthogonal to it, and you reduce the dimension, right? So instead of 300 dimensions, now you reduce it to 299, but now your embeddings are more gender fair. Right? Similarly, now if you want to make it race fair also, then you again reproject this on a race vector, and then you reduce the dimensions even more. Right? So you keep doing that until this particular value gets closer and closer to 0. Right? So instead of 300, maybe you'll end up with 200 dimensions, and you sacrifice accuracy and everything because now there's less information that you'll be sending to any upstream classifiers or ranking models. But now you're sure that, well, this is more gender neutral or race neutral. Yeah. So there's a lot of work happening, and right. So this picture is very similar to the feedback that we saw when we were talking about search engines. Right. So basically, there's a state of the world. Now there can be measurement biases in how you represent this world in data. It's instead of reoffending, you only have rearrest data, for example, right? So there's measurement bias. Now you then learn classifiers on this data, and there are actions taken, right? That you make rearrest decisions, you make hiring decisions, you make loan decisions based on whatever this is predicting. right? Plus there's ongoing data generation, so you're also giving feedback to the model, right? But what's more important is that these actions are influencing the world again, right? So this is where you end up with feedback effects, right? That if you have used data of rearrests, your models are biased towards blacks. You make decisions based on that, which have a higher likelihood of giving reoffending risk scores, rearrest risk scores for blacks, which will then make you police black neighborhoods even more. And it will become a positive feedback loop, which will basically keep amplifying, right? Can lead to self-fulfilling predictions that risk of recidivism among blacks is more and black localities will end up getting more actively policed, and it essentially reinforces the biases, right? So that's what you want to avoid. So everybody is with me? You get the big problem over here, right? That because of so many issues, right, your models are predicting certain actions, and these actions can actually reinforce some of these biases in society. Yeah. So that's the big problem that we're talking about. Yeah. So these problems, therefore, there are two types, right? One you can say can be allocative harms, like in hiring or criminal justice, where there's a higher chance of predicting blacks as right at higher risk of reoffending and so on, and these are right. So they are called allocative harms, that you're making a change in what resources are allocated for blacks or for whites, and which can cause feedback loops, right? Then there are what are called representational harms, right? That these are longer term. That once they end up with a feedback, it can actually entrench the stereotyping even more, right? And right, so that's the harder part to look at, right? So allocation, right, you can quantify it and you can still deal with it, but representational harm is harder to catch and to address, because then you're essentially talking about monitoring of this loop, right? This monitoring this particular relationship is going to be much harder, yeah, while monitoring this as an allocative effect is going to be easier. Yeah. So there's right a notion that you can, right, which you might see very frequently, that right, how do you, right, in what is the practice in law, right? So you know that there are anti-discrimination laws, right? India has, I think it's Article 12, which is for anti-discrimination, and similarly, right, all countries have laws against discrimination. So typically in the law, it distinguishes between disparate treatment, that in the process of the decision making was any bias, was there any discrimination, right? And which is similar to our notion of independence, that the decision making process should be independent of any sensitive attributes. Then law also typically looks at disparate impact, that the treatment may have been fair, but was the decision also fair, right? Which is related to this notion of sufficiency. Right? Precision of decision making is the same across sensitive attributes. Right? Typically, law has not looked at separation, which is error rate parity. Right? So that's something which the fairness community, fairness in AI community brought up as also being important. Right? Right, and law basically works in a similar way, that just like this epsilon value that we were seeing, right? That the differences should not exceed a particular threshold, right? That difference between this minus this should be within a particular bound. So that's what the law also typically says, that they say that there is evidence of discrimination if some treatment in the decision making process or impact of the decision making process, there are differences, right, which are more than this threshold, right? Right. So this is more for you to also situate that, right, different, you could have biases during the decision making process or in terms of the outcome of that process. And also another axis to think about it is whether these harms are in terms of resource allocation that is being made, or is it reinforcing some stereotypes, which typically happens, that you make allocative decisions, but these allocative decisions then have longer term effects, right? And representational harm is what is even worse, because then you're not really getting out of just like Iris, Marion Young, right? So recall what we saw in terms of Young's criticism of Rawls. just ensuring equality in terms of access to certain resources is not enough. Rather, you need to remove the source which is causing that inequality. Right? So if it is a stereotype against blacks or gender or caste which is causing it, then you can't really solve the problem unless you eliminate the factors which are causing this discrimination. Yeah. And that's where you then can't just look at decision making as having some notion of fairness and of decision making on an immediate basis, but you need to see how it plays out over the future. That if you have a particular decision making logic, then is it eventually going to eliminate these stereotypes which are there? Yeah. So that's what this particular paper that I've included in the reading list, that's what this also talks about, that right there are politics in this, right? Machine learning, right? First of all, you have to choose the fairness definition itself, right? Which is a political question, right? That what's the right definition to use, right? Which stakeholder am I trying to build this definition for, right? And then the point is that even though you would have a fairness definition, typically these are all allocative definitions. They try to bring some kind of equality in resource allocation, in immediate decision making, right? But what you actually need to look out for is that is this going to solve some of the stereotypes which actually cause this, right? So not just make sure that the stereotype is not reflected, but are you actually removing the stereotype in the long term? So that is where things like affirmative action come into the picture, right? That is not whether for a particular race or for a particular caste you're being fair in the decision making process, but rather you need to go beyond that. You need to give more advantages, more privileges, so that they're able to catch up, and that will remove the underlying inequalities which had been created. Yeah, that's the idea. So this is also a nice picture to think about, right? So here you have equality, right? But it doesn't really solve anything. Here you have something like affirmative action, right? That you've given, right? Now it's more fair, right? And this is where you've removed the obstruction, right? So this is actually what you want to get to, right? As Iris Marion Young says, that simply, right, having equality or is not enough, but rather you need affirmative actions, right? But eventually what you do need to get to is you need to remove the obstacle itself, right? Because unless you remove that, you'll always have to continuously keep, right? These things will keep changing, right? But you'll again have to keep continuously readjusting. So you all got the point about, right? One big point is how algorithms can have feedback loops, can set up feedback loops which can entrench whatever inequalities might be there. They can entrench it further. Second is data-driven algorithms like machine learning-based algorithms, right? They have certain characteristics that biases in the data can be reproduced, right? The biases in the data can actually reproduce unfair inequality, and you need some of these constraints and so on to make sure that it gets controlled, right? But that alone will not be sufficient, because to decide the algorithmic objective or to make sure that machine learning algorithms are obeying a certain constraints, you need to decide what those constraints are, which is a political decision. Right? And just again ensuring equality will not be sufficient. Rather, you need methods like affirmative action to eventually remove social processes that actually cause that inequality in the first place, right? So that is also very important, right? So essentially it's talking about limitations of technology, right? That what all can technology not solve, and how, if the technology is not done carefully, how it can actually entrench inequalities even more. Yeah. Right. So this is something we looked at a little bit last time, right? That who decides then, right? So you need the legislature instead of the courts. You need decision participation in making algorithmic choices. So later on, when we talk about design methods like participatory design, right? So over there, we'll also see some initial experiments that have been done, that how do you get people to participate in building algorithms, right? Or in deciding about what's a good fairness metric to use, right? So here, rather than rather than saying that do you value, do you want error rate parity or do you want demographic parity and so on, right? Because that will be hard for people to understand. The way we'll see, the way people were brought into participation was by giving them examples, right? So giving certain cases to them and saying, okay, would you prefer this solution or this solution? And then based on these preferences of people, then an appropriate, so then the classifier essentially then tries to make sure that it's living up to those preferences of people, because people would be thinking from different fairness perspectives. So it tries to, in some sense, you can say that it tries to build a classifier which, if some people are preferring independence and some are preferring separation and so on, so it tries to build something which is a mix of these things, right? And maybe you can then evaluate the classifier, that is it closer to independence, is it closer to separation? So that can also give you a sense that what criteria are people preferring in general, right? So that's some very interesting directions of participation in building algorithms. Yeah, right. And then these things are not straightforward, right? Because like we saw, there's typically a tension now between accuracy, which can enhance the welfare or utility of an algorithm, and fairness, right? And similarly, if you think about transparency, right? So the more fair and transparent you are, people will start protesting, and therefore your system adoption might get harder, right? Fairness and transparency also make automation harder, but they can also improve correctness, right? So there's a tension between many variables that, and that is also why this is largely a, right? So it's more of an argument that you can't run away from politics, right? Because when you're making a system, right, you're ultimately trying to figure out, right, should I be fair? What fairness definition should I use, right? To what extent should I be fair, right? Like on this Pareto curve, right? Where should I go on this Pareto curve, right? Should I have an error rate of this and be more fair, or an error rate which is lesser but it is a bit more unfair? Yeah, because this error rate is impacting my profit, right? So all of these are, right. So the point is that it's a political decision, right? That when you're building technology, you're not really running, you're not running, you can't run away from politics, right? That's one of the main points, and we see this coming up again and again, right? Just like we saw in user interfaces, we saw in data privacy and so on, right? So similarly, right, you see signs of, right, that you can't isolate yourself from politics over here. Yeah. Okay. So now, right, all of this, of course, is now recognized. So this came out in 2017. ACM released this, right, like a model code of conduct, where, right, to say that algorithms, right, owners, designers, users should be aware of what the algorithm is doing. They should have access to redressal, that in case the algorithm has made some decisions that they want to appeal against, entities running these algorithms should be accountable. You should try to make the algorithms explainable. This we'll look at soon enough. Briefly, right, that we'll see how classifiers, right, can be made more explainable. The data that you're training the machine learning models on, right, where did the data come from? What are the characteristics of the data? That becomes important. Auditability, that the models you're building, are you also giving some information about what kind of decisions are they producing, so that people can audit them, that are they making fair decisions or not. Validation and testing is important, so give out information on what data set, what did you validate it on, what are the accuracies, what are the fairness measures on those data sets, right? Accuracies for blacks versus accuracy for whites, right? So I mean, now that there's greater understanding, there are all these principles which are being given. But again, right, one of the problems is that regulation-wise, none of this is sort of guaranteed. Right? GDPR does say that, okay, your algorithm should have explanations. Algorithm should not be completely automated. There needs to be a human in the loop for this category of algorithms, right, which are about hiring decisions or loan applications and so on, right? So policy is also evolving, and not that it's not. But then we also saw, like with data privacy, that the policies can sometimes be hard to enforce because they're not specifying the technological aspects in as much detail, right? Typically, policy from a standpoint of law is essentially giving an opening for people to appeal, but the tools that people may have available to them may not be very powerful. Sort of the onus to prove has been put on people, right? Rather than actually dictating for companies and governments in terms of what processes they should be following. Yeah. So this is an evolving landscape. Yeah. But again, one of the main messages being that you do need, I mean, you need responsibility and everything, but then also, right, it is actually a political arena as well, right? Because you're really balancing between profit, between fairness, types of fairness. So all that is quite complex, right? So let me mention this also on algorithmic auditing. That a lot of these models, right, even though you're saying that, well, things should be open and transparent, well, it's not actually the case, right? Ranking algorithms by Google or recommendation algorithms in Amazon and so on, right? They're all closed systems, right? There's no transparency. So something which is done very actively is algorithmic auditing. That can be launch certain queries and look at the output. And by examining the output, can we tell whether there are any biases or not? Right? So here there are many examples. People wanted to check whether Amazon, for its same products, it's giving different prices in different cities, and what might be the reason for that. So here what people did was they set up local proxies in different cities so that when traffic goes via these proxies to Amazon, Amazon will think that, okay, some searches are being launched from city X, some searches are being launched from city Y, and so on. They actually then found that the prices that Amazon was giving to people in city X versus people in city Y, they were differing because based on whether which city had more competitors, right? Which city had more Walmart or Costco stores in the US, right? I mean, equivalent in India would be like Amazon biasing its results based on whether you have a big bazaar close to you or not. If you're in a city where you have a big bazaar close to your home, then Amazon is likely to show you a better price so that you buy from Amazon instead of just going out to big bazaar and getting it, right? So they showed this by setting up these local proxies in different cities, right? That showed that it was sensitive. The prices are sensitive to the presence of brick and mortar competitors, right? Similarly, they did zip code level targeting, right? That our advertisements targeted at the zip code level, right? So here they put browser extensions on people's computers to track which ads were shown on popular websites, and again, right, found evidence, right? So another one I'll mention, right, which some of you were interested in doing for your projects, right? Testing for information leakage, right? So here again, you test it through, right? So you set up dummy user accounts on a platform. You emulate different behavior in these accounts. So with some user accounts, you browse a certain, so if you want to check whether some websites are leaking, are tracking your personal information and sending it to other companies, right? So with some dummy accounts, you browse what you think are information leaking websites, and another group which through which you another group of dummy profiles through which you do not browse, right? And then you test what ads are showing up on a common set of websites for both groups, right? So if you see that, okay, group A through which you were browsing some websites, you're seeing a different set of ads than through group B where you were not browsing these websites, then it means that these websites are basically leaking information to those advertisers. Yeah, these websites are sharing information with advertisers in terms of that you browse those websites. Yeah, so these are essentially now about auditing the operation of these algorithms from the outside. So that's the idea. Yeah.
Sir,
Yeah.
I have a question here.
Yeah. Yeah.
So like sometimes you do not even need to go to the website, and like the Google search itself records like what you are browsing, and
Correct.
then the Google AdSense shows like the ads on those sites where like Google AdSense is present.
Hmm.
So like in that case, like should we say that it is information leakage? Because like we are using the Google browser and we are willingly providing it with information.
Yeah.
So is it considered information leakage or not?
No, that won't be information leakage. That is essentially tracking, right? That Google has basically through AdSense, right? I hope people understand, right, what is meant by AdSense over here, right? Maybe I'll just show it on the board. Basically, what AdSense and things are doing is right that if you go to a particular content provider, let's say Times of India, right? Over here you have Times of India is showing right wants to show some ads, right? But right Times of India is not showing these ads. Rather, these are essentially frames within which Google has embedded. Google is the one which is displaying these ads, right? So, and because Google has put this information, right? So, along with it, Google has also put information about that these ads are being shown on a Times of India page. Yeah. What therefore this enables Google to do is to do a lot of tracking, because once this ad is loaded, then Google knows that okay, my ad was loaded on a Times of India page, right? Because right, so it gets a hit. So each time, so if you look at your HTTP requests, that when you load a Times of India or Indian Express or I mean anything which shows ads, if you load that page, the content over here will come from Times of India. So request will go to the so you will see requests going to the Times of India server and data being downloaded over here. But in parallel, you will also see requests going to Google and DoubleClick, which is Google's an ad network that Google purchased, and ads are therefore then downloaded through Google, right? But because these requests when they go to Google, right, they are going from this page, so Google knows that okay, these requests I got it from this particular web page, and then it returns the ad, right? So Google knows therefore that I got a request from this particular page, right? And what Google is also then able to do is that because these requests are going via the user's computer, right? So ultimately, right, this page is on a mobile phone, right, with a particular device ID. So that becomes one way to track, right? Or through a cookie, right? So here Google has also put in cookies, so that now through this computer, through this browser, today you visited Times of India, tomorrow if you visit Indian Express or you visit NY Times, and all of them are using Google's ad network, then they're all getting a ping. And Google is continuously therefore tracking that okay, you with a particular an ID which was stored in the cookie or with a particular device ID, you are the same person who visited a page on Times of India, who visited this page on Indian Express, who visited this page on NY Times. Yeah. So and this is the information therefore that Google is collecting. So ultimately what Google is able to build as a database is ID and the fact that you visited Times of India page X, you visited Indian Express page Y, you visited NY Times page Z, and it's able to keep track of all of this information. And it uses all of this therefore to understand your user characteristics, based on which it determines what are the ads that I want to show to you, right? So that's how all of this works, right? So this is not information leakage per se. This is because these companies are actually paying Google. Google is tracking it in this way, right? Information leakage would be where Times of India can also track you through cookies. Times of India can also track you through device IDs. Let's say, right? Let's say now on another web page, right? Let's say now you go to, let's say Aaj right? Now over here, let's say Aaj is not using Google, right? But Aaj is also showing you certain ads from which you can tell that that it's showing you these ads because it knows that you went to TOI. So that is actually, you can say that is info leakage, because here these ads are not coming in through Google, but Aaj is showing you these ads. But based on the mix of the ads, you can tell that Aaj is showing me these ads because it knows that I visited these pages on Times of India, right? So there you could say that, well, okay, Times of India is causing an information leakage.
So, but like, won't it be like difficult to then track information leakage, because most of the things we search on Google and most websites use AdSense, so we won't know if the information has been leaked through some website or like through our Google search.
Yeah, no, that's true. So you can't, well, you'll have to define the question, right, more precisely. So I think you're probably talking from your project's point of view, right, where we were discussing some of this on email, right? Right. So, I mean, I don't remember exactly what the context was, but the point is that you'll have to then right, look at it in a very right specific example. That I think this particular website could be leaking information, right? And then you just track it for that. But you can build a general system for tracking, but it will become right. You won't be able to like find evidence if you don't know what to search for, right? So that's the difficult part. Right? But even then, I mean, like from the project point of view, I think even if you can show some kind of a mapping that which websites are using Google, which ones are using other trackers, right? But Google could also be leaking information, right? So I mean, another example is, let's say, right, you go to a different website where these ads are being shown by some other company, right? These ads are, let's say, being shown by Facebook, right? And now from the mix of these ads, you can figure out that, well, somehow Facebook knows this information as well, right? So then you know that, okay, Google is actually feeding information to Facebook, right? So that is the point. Yeah. Which ad networks seem to be sharing information? That's something that would be interesting to explore, right? But of course, right, you'll need to be precise on what are these ads that I want to search for. Yeah. Overall, I mean, you got a sense of right how tracking works in browsers,
Yes.
and this is not the only thing, right? Because now with GDPR and everything, right, you can't just arbitrarily set cookies, right? You need to seek permission from the user. Now we just, of course, randomly keep giving permission, but lawyers are reading those terms of service, and lawyers can say, right, that no, you should not be actually archiving this information. Right? Similarly, Apple and some companies are now allowing you to mask a device ID. So on a device, you can say that I don't want my device ID to be revealed to anybody else, right? So therefore, if this ID information is not available, then Google will not be able to build up your user profile, right? And but other methods are now developed, which are called device fingerprinting methods, right? So device fingerprinting is where other kinds of data could be collected, maybe based on how much how you browse, how you scroll your applications, or the location, right? So websites can still track location, right? So you might not be giving your cookie some IDs which are stored in cookies, or you might say that I don't want to share my device ID, but maybe through a combination of your location and how you browse your device, the device type, right? Device type is shared with the companies because based on that they render information, right? They'll know that, okay, what's your screen resolution? Based on that they send you a resolution, an image with the right resolution, right? So device type is shared, location is often shared, and even if some other information is shared, then they can still make out fair degree, right, who you are. So even though you might stop sharing device ID, but other characteristics can lead to this de-identification, and they can still build a profile. Yeah. So that's what the whole game is about in advertising, actually. Right? And how do you track, and then how do you build a user profile, and then based on this user profile, how do you recommend precise ads which you're more likely to click? Right. So that's the whole that's the whole economy of the internet. Yeah. How
Okay,
it
sir.
works today.